Well, hey everybody, Mr. Reeves back with you yet again with some more IXL practice skills. So we are currently working our way through some 7th grade math skills way down here. We are looking at expressions and properties, and today we're going to be looking specifically at 10, 11, 16, and 13. That's right, I didn't make a mistake. In that order, 10, 11, 16, and 13. Looking at the properties of the associative property, the commutative property, the identity property, and the distributive property, with a little factoring thrown in just for fun. All right, so hopefully you've taken the time to do the preparation, to watch the Khan Academy videos and do the practice, so this should not be too difficult at all. All right, 7 plus 6 equals 6 plus 7. They have switched the order around, and as you know, that is the commutative property. All right, 4 plus 9 plus 7, 4 plus 9 plus 7. You notice the order has not changed, but the parentheses have moved. The parentheses tell us what to do first. We're changing what we do first, not changing the order of the terms. That is the associative property. All right, same thing here. Notice it goes 7, 2, 4, 7, 2, 4. The order of the terms has not changed. Simply the parentheses have moved. That is the associative property. All right, let's skip up and see. Do they have anything new here? All right, 8 is equal to 8 plus 0. We have added 0. You notice that we start and finish with the same thing. That is the identity property, when you start and finish with the same thing. And in addition, you add 0. Of course, in multiplication, you multiply by 1. 2 times 9 equals 9 times 2. We've switched the order around. That is the commutative property. All right, 8 plus 1 equals 1 plus 8. Again, commutative property. Can they take us up to a more difficult level? N times 1 equals n. Notice we start with n, we finish with n. That's the identity property. In this case, we multiplied by 1. That is the identity property of multiplication. And what about the challenge zone? Which equation shows the associative property of multiplication? Remember, associative property, you do not change the order of the terms, you simply move the parentheses. That would be this third one right here, right? Because this one says to do 4 times 9 first, this one says to do 5 times 4 first, but notice 5, 4, 9, 5, 4, 9. The order of the terms did not change, just the order in which we did the operations. All right, I'm going to go ahead now and move on to our next skill. That was R10. Now we're going to move up to R11, and now we're going to be using the distributive property. So remember, in the distributive property, you're going to multiply by whatever's outside the parentheses by the terms inside. So I'm going to get 2 times 5, which is 10, and then I'm going to get 2 times 7u, which is 14u. Again, I did 2 times 5 plus 2 times 7u. All right, this one, they moved the 3 to the other side, but it really doesn't matter, all right, whether we put the 3 in the front or the 3 at the end. I'm going to do 3 times 7x, which is going to give me 21x. And I'm going to add that to 3 times 3, which is going to give me 9. 21x plus 9. Same thing here. I'm going to do 2 times 2n, which is going to give me 4n. And then I'm going to do 2 times 2, which is going to give me 4. All right, I'm going to skip up to the next level. All right, now they're throwing in some negatives, which might make it a little more challenging. Notice this is not subtract 5. This is times a negative 5. Well, what's a negative 1 times a negative 5? That is a positive 5. And what is a negative 5 times an s going to give me? That's going to give me a negative 5s. But instead of putting plus negative 5s, we're going to put minus 5s, because that's considered more simplified. Again, a negative 1 times a negative 5 gives me a positive 5. A negative 5 times an s gives me a negative 5s, but instead of putting plus negative 5s, we're going to put minus 5s. All right, what about the next level? 5 times negative 9, that's going to give me negative 45, plus 5 times 5j, that's going to give me 25j, right? 5 times negative 9, negative 45, 5 times 5j, 25j. Can we get up to the challenge zone? What are they going to do to challenge us today? Oh, they've given us decimals. Well, I should have known this was coming and had my handy dandy calculator ready. All right, so it's absolutely okay to use a calculator for what we are doing, because the point of what we're doing is to know the distributive property, not to review decimal multiplication. All right, so I'm going to do 2.7 times 6.7. Now again, I know they're both negative, but a negative times a negative is a positive, right? So what do I get? I get 18.09, right? And then I'm going to put a minus, because this next part is going to be a negative times a positive, right? Which is going to give me a negative. And then I'm going to get 2.7r. All right, again, adding a negative is the same as subtracting a positive, but subtracting a positive is considered to be more simple. All right, so again, we're in the challenge zone. All they're doing in the challenge zone is giving us decimals instead of integer values, but with the calculator, they're really not any more difficult. All right, so I'm going to now skip from R11 to R16. All right, so now we're talking about factors. So now we're looking at doing the distributive property in reverse. Okay, so is 10 a factor of 40w and 50? Well, does 10 go evenly into 40? Yes. Does it go evenly into 50? Yes. So it is a factor. All right, is 10 a factor of both of these? It sure is. All right, is 9 a factor of both these? In fact, no, it's not a factor of either one. 9 does not go evenly into 60, nor does it go evenly into 50. What about 35t and 45? Well, 9 goes into 45 evenly, but it does not go into 35 evenly, so the answer is no. All right, I'm going to skip up to the next level. All right, now they're actually asking us to factor it. So now we have to find that factor, and we're looking for the greatest common factor of 45 and 72. Well, what is the largest number that you know that goes into both of those? I believe it's 9. So we're going to divide 45y by 9. Well, 45y divided by 9 is 5y. Do you see how if we multiply 9 times 5y, we would get back to that 45y? Minus, and 72 divided by 9 is 8. And you can always check your factoring problem by distributing. 9 times 5y would be 45y, minus 9 times 8 is 72. So do you see how factoring is undistributing, or it's doing the distributive property in reverse? All right? And we will submit that answer and take a look at the next one. All right, what is the greatest common factor of 21 and 9? Well, the greatest common factor of 21 and 9, I sure believe, is 3. What is 21s divided by 3? Well, that is 7s. Minus, what is 9 divided by 3? It is 3. And again, check your answer. What is 3 times 7s? It's 21s. Minus, what is 3 times 3? It's 9. So the great thing about factoring is you can always check your answer by distributing. All right, let's jump up a level. Okay, same idea. Greatest common factor of 20q and 12r. All right, now you might say, well, 2 goes into both of them, but bigger than 2 would be 4, right? So I'm going to factor out a 4, and then I'm going to say, what is 20q divided by 4? Well, that would be 5q. And what is 12r divided by 4? Well, that would be 3r. Don't forget those letters, right? And again, 4 times 5q, 20q, it works. Plus 4 times 3r, 12r, it works. All right, next level. Ooh, 3 terms. So what is the greatest common factor of 32t, 36u, and 20? All right, well, I believe we're back at 4 again. All right, and since that's all it has in common, I factor out the 4. What is 32t divided by 4? Well, that would be 8t. Plus, what is 36u divided by 4? Well, that would be 9u. And what is 20 divided by 4? Well, boys and girls, that would be 5. Okay, how about the challenge zone? What do they have awaiting us here? Same thing, 3 terms. Greatest common factor of 6u, 6v, and 54. I believe it's 6, right? I'm going to factor out the 6. What's 6u divided by 6? Well, it's just u. What's 6v divided by 6? Well, it's just v. And what is 54w divided by 6? Well, that is 9w. All right. And again, if we were to distribute, we would see that we are correct. All right, last one. Greatest common factor of 36t, 81u, and 45, 9. We're talking 9. 36t divided by 9, well, that's going to give me 4t. Plus 81u divided by 9, that's going to give me 9u. And finally, 45 divided by 9, that's just going to give me 5. Ka-chow, fantastic. And let's finish up now with skill R13. All right, I think you'll see why I saved this one for the end, because it has all the properties together, and we are looking at equivalent expressions. So they want us to know how we can rewrite 3y times 8 using the commutative property. Well, commutative property says to switch the order around, so I flip-flop them, and when I flip-flop them, instead of 3y times 8, I get 8 times 3y, and now I have 24y. Super, look at that. All right, now the associative property does not move the order of the terms. It moves the parentheses, right? So it's still going to be 6, 9w. Now it's just the parentheses are at the beginning instead of at the end. And what is 6 times 9? It is 54. We get 54w. All righty. Now we're going to use the distributive property. So 8 times 5t plus what? 8 times 2. And we get 40t plus 8 times 2 is 16. Alrighty. So they had 5 times 6r plus 5 plus 6 times 6r plus 5, and they rewrote it as 5 plus 6 times 6r plus 5. This is a little bit tricky, this one here. But do you see, guys, how these two, that and that, are the same? Right? And that's right there. So what have they done? If I had this, I could use the distributive property, right? I've got 6r plus 5 being multiplied by 5 plus 6, right? 6r plus 5 being multiplied by 5 plus 6. So that is the distributive property. Kind of a tricky one right here. But when you see two of the same thing, look for those two things that are the same being multiplied by two things that are different, that are either added or subtracted. That is your distributive property. As is this one, distributive property, same thing, right? I've got a 3 there, and I've got a 3 there, right? 3 plus 3, and I've got a t there and a t there. So it's actually the t that is my part that's the same. It's unfortunate. I wish they hadn't made both of those 3's, because you could do this either way, right? This could be 3 times t plus t, or it could be t times 3 plus 3. But no matter how you slice that cake, it is the distributive property. All right, as is this one. Wow, they are really distributive property happy, aren't they? 7p plus 7, they are factoring out the 7. That is the distributive property. All right, finally, one that's different. What did they do? They went from 9 plus 8r plus 8 to 8r plus 9 plus 8. They switched the order of the terms. When you switch the order of the terms, and an addition problem, that's the commutative property of addition, right? And then they added the 9, and the 8 together. All right, let's skip to the next level. All right, what have they done here? What have they switched? They have moved the parentheses, right? 7y plus 6, 7y plus 6. The terms are in the same order. So this is going to be a 9. 7y 6, 9, 7y 6, 9. That is the associative property of addition. Whoops, addition, Mr. Reeves. And then what is 6 plus 9? It is 15. All righty. Okay. Ooh, this is starting to look a little scary here. What do we have here? r plus r plus r plus r, and what did they change it to? They changed it to 1r plus 1r plus 1r. That's the identity property, right? Which says if you multiply by 1, you get what you started with. And then what did they do? They factored out that r, right? They took the r from each term and moved it to the outside. And as we discussed, that is the distributive property. When you take something that's the same on every term and you move it to the outside of the parentheses and change it to a multiplication problem, that's what you get. And what is 1 plus 1 plus 1 plus 1? It is 4r. If you're thinking, couldn't I have just gone r plus r plus r plus r is 4r? Absolutely you could. This just shows the formal mathematics of that. All right. Same thing here. Okay, 6r equals 6 times. So, what do they want me to do? I think they want me to switch the order around, right? 6r times 6 is 6 times 6r. That is the commutative property of multiplication. But guys, what is 6 times 6? That is 36 with that r on the end, right? 36r. All right, can we skip to the challenge zone? Okay, what do we got going on here? Looks like distributive property to me, right? We've got 4 times 4q, and we've got 4 times 5. That's going to be the distributive property. And then, what is 4 times 5? Well, I believe that is 20. And then, they want us to switch the order around. Instead of 20 plus 16q, they want it to be 16q plus 20. What do you call it when you switch the order around in an addition problem? I believe you call it the commutative property of addition. All right, last one. And then we're going to call it a day here. We've got 9 times 9r plus 2q. That part's exactly the same. All right, what do they done here? Well, that 2q has moved over there, so that means I'm going to put 9r over here. When you switch the order around, what's that called? That's called commutative, in this case, commutative property of addition. All right, but now what do I have here? I have 9r plus 2q right there, and I have 9r plus 2q. I have two things that are the same, and now I have factored out that 9r plus 2q. See, I had two 9r plus 2q's. Now I only have one. So that factoring actually is using the distributive property. And then, what is 9 plus 2? It is 11. And that, ladies and gentlemen, is going to be the end of our video for today. I hope this was helpful for you as we are looking at expressions and properties of expressions. Have a great day. Until next time. Bye.